Good morning. So I've been thinking about a little problem here and how we're seeing a lot of different problems. We have some Z-axis stuff and we have some Y and A-axis stuff. We have some motor issues. And there's a lot of variables there. And there's also a lot of variables present because of the modifications made to the table. So I'm trying to differentiate right now between modifications made and how that would affect the physics of the table, as well as how it would affect the way the control box is physically run. Because there's a weird fine balance that's made with this system that, when adjusted, can have interesting results. So here's what I'm thinking. One, if you're getting some mid-table, something happening mid-table, one of the first things that I like to check, whether it's mechanical or electrical, I always check the distance between the outside of the gear track at this point to the outside track there, or the outside of tube here to the outside of tube on that side, outside of tube middle, front. And make sure that I'm not experiencing any variances between my legs here and, my gantries here at any point. So there's no variance in mid-length. Like usually you can deal with a 1/16 maybe of difference. Even then, that'll cause some pressure on the motors. You want almost no variance or very little variance here between these two gantries. So that's something that I initially take into consideration whenever dealing with processes that have mid-table problems, because really outside of that there really is no difference on how the control system reacts, because the control system, because of the way it's a floating zero and it doesn't have a positional sensor mounted to each motor so that it has absolute positioning, because it doesn't have that, regardless of what position it is on the table, it shouldn't run into any issues that wouldn't be consistent with also the back and the front at all times, as opposed to just strictly the middle. So the only variable that we have in the middle is, of course, the gantry distance. And with the presence of the new cable track system, you also have that variance on the weight and pull of these cable track systems. So just things to take into consideration as we're working towards solving this problem. As for the Z-axis motor, why we're not getting that accuracy is rather confusing to me. I do want to check something, which is it's a simple test of placing a piece of material on the table and then running to double check positional accuracy. This will let us know if it's strictly a positional thing or a G-code thing. Now, we do realize that it's a G-code related issue based off of what we're seeing in Mach 3. But again, I just like to check my variables. Positional accuracy is also part of that issue, and we're going to check that there. If we've reset the profile, then we should be back to essentially stock settings on the right CNC table. So Mach 3 should be set at exactly the same variance as the rest of the system. That's just how that would go. Unfortunately, because it is a computer and it is an electrical system, there are chances for small unforeseen issues, and we want to make sure that we address those. So here are the solutions that we have to fix this problem. Likelihood is these motors aren't the issue. So I wouldn't recommend actually replacing the motors. The motors themselves are pretty static, and I haven't had a motor go bad. I've only had one motor go bad out of all of the motors that we've ever sent out. So, let's say we did send out 300. That's 1,200 motors that are out on the market that have had no issues except for one motor. So pretty good running track record on those. Not likely to be the case. One way we can test that is you said that one motor in particular is just free spinning in your hand, or you're able to spin it by hand. Let's double check and make sure that it's just that motor or it's not the enable function on that particular driver. So what I want to have you do is do a substitution. So you're going to take an X and substitute it for A or whatever motor that is, switch it out with another motor, turn on the control box and see if it's going to give you that same level of resistance or not. If it gives you the same resistance or same lack of resistance as before, then it's possible that the wiring on that motor is wrong or damaged in some way, in which case we can then swap that out. Not likely, but something we want to check. If the switching of the ports results in the same in the proper enabling, so you can't easily twist it by hand. I mean, yes, you can twist it when you torque it over 420 ounces, but you know that's why it's called a 420 ounce motor. But in this case, when you swap these out, and if it locks up, that means that it's something in the control box itself. It's a port that isn't properly enabling or isn't getting enough power in order to lock that motor correctly. In which case we would talk about switching out the driver, or we'd actually be talking about switching out the control box. But I want to get this running as soon as possible. So realistically, what I would like to do is switch out the control system. My only concern is we have a price CNC hookup on your end, and it would have to be reintegrated, and I don't want you to have to go through that, because reintegrating a price CNC machine is just more time down. So it's a concern, but again, something I do want to address. If you could potentially send me a shot of what modifications you've made to the table, I'd like to just take all of those factors into consideration as well. Again, any of the changes that you may have made to the system, I am concerned about how the price CNC in particular is affecting the overall height of the floating head as it's working. I am not entirely sure how that is specifically working in the system. And I know that because price CNC integrated through our port, integrated into the control box, which is then integrated directly into the computer system, has Mach 3 control, so it's directly feeding the signals into Mach 3. My concern is that there is something that we're not accounting for in the price CNC system that is taking hold and allowing for that change in the Mach 3 screen, because the THC is run through Mach 3 and then kicked back out, rather than being a completely separate system, because Mach 3 is translating those signals. And because it's a serial port integration on a Mach 3 system, regardless of the THC on it, that information is still controlled and parsed out and then translated by Mach 3 onto this table. So if there's something that the price CNC system is doing on the touch-off or directly after the touch-off, or in relation to, in any respect whatsoever, then we need to make sure that that's taken into consideration. So if we can remove that as a variable, if we can remove the THC as a variable, set it to status normal from when we first got the table. So let's say, I don't know if the floating switch that you have is, the floating head system is integrated with the price CNC or not. I don't know what you have running there. But if it is, I would like to be able to switch it back to direct control over the control box, if it's not already. If it is already switched to, if it's back to normal control box, if it's plugged into where it's plugged in and controlled where it is from our original standpoint, then this whole part of the conversation has been for naught. But again, I'm just checking my variables here, 1, 2, and 3. So let's go over the worst and best case scenarios here. Worst case scenario, what I want to do is have the control box and computer swapped out and potentially replace a motor. That is worst case scenario. I don't believe that that's going to be the case. I honestly have the suspicion, based on the number of unique cases that I see with technical support, we don't see a lot of motor replacements. What we do see are potential driver replacements in the system, or something, a programming change in Mach 3. 9 times out of 10 is just a profile reset, and it works just fine. But since we've done that, this is where we start to get escalated. So there we go. Those are the current thoughts. Sorry for drawing on as long as I did. I'm still trying to process all of this and make sure that we do have all of the accurate information to get this table running for you as best as possible. And again, by understanding the variables and the things that have changed since you've gotten the table will help me further diagnose the issue, and potentially help you as well, so that we can both figure out exactly what's going on. Thank you.